my name is Lieke Melsen. I'm a PhD student at the Hydrology and Quantitative Water Management group here in Wageningen. And today I would like to tell you something about model specification uncertainty in hydrological models. Well, I admit that it sounds rather technical, so I first go back to the basis of today, which is water. Well, water is often seen as some sort of life essential. We need to drink 2 liters of water a day. We need 2 liters of water a day, but next to that it's also closely related to our food production. So water is essential for all of us. But on the other hand, it can also be quite devastating, for example, in the form of a flood. Or, even if we have too less water, it can also cause problems in the form of a drought. Yield losses, impacts on water quality. Well, these are enough reasons for us hydrologists to model water surface, water levels and discharges. So these are our motivations. We use models for that, and we use them at different scales. For example, in the Rietholzbach catchment in Switzerland, I modeled surface water levels in a very small catchment. But of course, we can also extend this area to a larger region. For example, the Tour Basin, which is a tributary of the Rhine, or eventually the whole Rhine Basin. Or what we finally would like to do is to project water levels and discharges over the whole of Europe. But of course, I'm not the only one here working with models. All of you probably have this experience. We just discussed it. Models are not reality. There's always some uncertainty involved in models. And it's just a simplification of the complex reality. And there are 3 main sources of uncertainty in models. The first one is the data input uncertainty. So this is, for example, when you work with climate models, the climate projections can be uncertain. But also in hydrological models, it can be measurement errors in your precipitation measurements, for example. The second point of uncertainty is the model specification uncertainty. This is uncertainty in the parameters of your model. How do you determine that? What's the exact value of the parameters? And the third, last but not least, is the model specification uncertainty. So your model is always a simplification, and all the assumptions and the simplifications that you made relative to the real world, that's your model structural uncertainty. Well, all these uncertainties add together to the total uncertainty of your model. But I will mainly focus on the specification uncertainty. So, well, that sounds technical, and now I want to give you a small example of parameter uncertainty in a model. What I show you here is the response surface of a very simple model with only 2 parameters, alpha and beta. What you see is the model performs well in the red areas and bad in the blue areas. And you see a clear correlation between the 2 parameters, which actually means that you can express alpha in terms of beta or the other way around. So even with this very simple model with only 2 parameters, it's already over-parameterized. And also if you want to physically interpret the values of alpha and beta, we can get problems because we don't know which value they really have. Another thing is, I show here the same response surface for the same, or another response surface for the same model, but now I used a different objective function. And you see that this objective function leads to different parameter values. So for the lower one, I had an objective function which might be focusing on droughts, while for the higher one, I used an objective function which puts more attention on floods. And what you see now is that this model is not able to describe both floods and droughts with the same set of parameters. Well, this is just a very simple example. But what you will see now with increasing computational power is that hydrological models have become more and more complex. It's not unique anymore to find models with over 60 parameters. And of course, in many of these models, you can find these kind of errors. And therefore, for the coming years that are left in my project, I would like to decrease specification uncertainty in these complex hydrological models. And hopefully, our projections will be less uncertain in the future. Thank you.